Good morning. I thought it'd be a good idea if we went over the Section 7.3 review. Uh, I know in a previous video I got through problems 1 through 6 and even showed a solution for number 7. I have an alternate solution for number 7, so let's start there. So instead of doing the quotient rule here, why not say that 1 over tangent x is cotangent x? And that will give us the product rule. The advantage here is that this results in a lot less simplification. So here we're just rewriting this. We're not doing any calculus, so no y prime on here. This is just y equals e to the x cotangent x. So y prime is the first one times the derivative of the second. Derivative of cotangent is negative cosecant squared plus the second function, that's the cotangent, times the derivative of e to the x, which is e to the x. Okay, and then just a little bit of cleanup here. We take and we rewrite this as y prime equals, and we factor a negative e to the x. So out of both of these terms, I've taken a negative and an e to the x. That's going to leave us cosecant squared x here, and then you factor a negative out of a positive, and of course that leaves you the negative cotangent x. Okay. Number 8, a lot of chain rule happening here. Okay, so what's the derivative of the secant of blah? Well, it's secant blah tangent blah. And what do we do with the argument to the trig function? We leave it alone. That stays the same. It's out here when we actually apply the chain rule that we take the derivative of the argument to the secant function. And so the derivative of e to the x squared is e to the x squared times the derivative of x squared, which is 2x. So just rewriting this in a little bit more nicer form, we write this as 2x e to the x squared secant e to the x squared tangent e to the x squared. Okay. Moving on to integration. The antiderivative of e to the u is e to the u plus c. Which leads us to number 10, the natural log of e. Just trying to make sure you guys are awake here. The natural log of e is just 1. So the antiderivative of 1 dx is just x plus c. Next problem, number 11, a little bit, a little bit more complicated, forcing you to do a u substitution here. So with the antiderivative of e to the blah is e to the blah, provided that we have this form, this e to the u du form. Well, and if we do our u substitution, you can see we do have that form, because du is equal to 5 dx. So du over 5 is equal to dx. So I'm going to replace this dx with du over 5. Now we're looking at the antiderivative of 1/5 the antiderivative of e to the u du. And the antiderivative of e to the u du is e to the u plus c. We still have that 1/5 out in front. And we've got to do our back substitution. And we end up with 1/5 e to the 5x minus 3 plus c. Okay. Moving on, number 12 here. Boy, this looks complicated, doesn't it? Okay. But remember, when you're doing antidifferentiation, we only have 4 things that we can let u equal. We can let u be the thing being raised to a power. We can let u be the argument to the trig function. We can let u equal the denominator. And then lastly, we can let u equal the power on e, which is what we did in the previous problem. Okay, so if you just kind of stick to those 4 different possible u substitutions, that's going to get you through about 90% of the problems. Okay? With some of the other problems, you have to be a little bit more creative with. But here, we're just going to let u equal the power on e. So we're going to let u equal the 2 over x squared. So then, so that I'm going to rewrite that as 2x to the negative second. Put that in a derivative-friendly form. So now we're going to take the derivative of that. And the derivative du is equal to negative 4x to the negative third dx, which when you write this with positive exponents, you get du is negative 4 over x cubed dx. Well, there's our dx over x cubed, and then we'll have to run a negative 1/4 out in front to get this last form. So 1 over x cubed dx is equal to du over negative 4. When we do the integration, we get the antiderivative of e to the u is e to the u, the negative 1/4 stays out in front. We do our back substitution and we're done with this problem. Okay? Let's take a look at this next one. Again, when you're doing a u substitution, you have 4 choices. What we're going to choose this time is we're going to make that second choice. We're going to let u equal the argument to the trig function. So here the argument to the trig function is e to the x squared. So we're going to let u equal e to the x squared. So the derivative of e to the x squared is e to the x squared times the derivative, got to do the chain rule, times the derivative of x squared, which is 2x. So if you look at what we're asked to integrate, I don't want 2x e to the x squared. I just need an x e to the x squared. So we're going to divide both sides by 2. We get du over 2 is equal to x e to the x squared. Now we can do our substitution. So x e to the x squared dx, all of that is du over 2. And then our substitution is the cosine of u. So now we've got 1/2 the antiderivative of the cosine of u du. So this is equal to, well, the antiderivative of cosine is sine. So we have 1/2 the sine of u plus c. And we're going to do our back substitution. And we have 1/2 the sine of e to the x squared plus c. Okay. And lastly, number 14, we're going to looking at our what we can let u equal. We're not going to let u equal the argument to the trig function. We never let u equal x. We are going to let u equal the exponent on e, this 3 cosine of x plus 4. So let u equal 3 cosine of x plus 4. So the derivative of u du is equal to, let's see, the derivative of cosine is negative sine. So we've got negative 3 sine of x dx. Divide both sides by negative 3, and we've got du over negative 3 is equal to the sine of x dx. Sine of x dx. There, that's what du over negative 3 is. So now we've got negative 1/3 du e to the u. So when you take the antiderivative of e to the u, you get e to the u plus c, which is equal to negative 1/3 e. We can do our back substitution to the 3 cosine of x plus 4 plus c. I hope this tour of the solution has helped. As we progress, we're going to get more into problems like we saw in chapter 4 and like we saw in chapter 6, where applications of the derivative and applications of the antiderivative. Okay, so talking about increasing, decreasing functions, figuring out where functions are concave up, concave down, doing volumes of rotation. We're going to rotate natural log of x around the y-axis or the x-axis. We're going to find the resulting volume. Okay, so all of those techniques are still in play. All right, we'll see you in the next video.